Okay, so here we're going to look at solving some problems with right triangles. A couple key terms that are useful when working with triangles and angles is the angle of depression or declination or decline. This is when you go down from the horizontal. So we have a horizontal line here, it goes down. The idea would be if you were looking straight out and had to look down to see that, then you're declining, you're depressing, and that is what the angle would draw out as. In the case of an angle of elevation or inclination or incline, starting from straight out, you're going up from that horizontal, so you're looking upwards. So a couple questions using these concepts and the trigonometric ratios that we've been discussing in the previous video. One, a radar shows an airplane is 50 kilometers away along a 20-degree angle of elevation. So that means we're looking at a situation like this, where the radar is looking up towards the airplane. Find the airplane's altitude and ground distance to the radar that is 100 meters off the ground. So we need to draw a diagram. Best idea, draw a diagram. So I got this radar tower or something, I don't know, the radar's up here like that somewhere. It's about 100 meters off the ground. And then I got an airplane up here somewhere, my fancy airplane. Now, the airplane is 50 kilometers away at an angle of elevation. So if we measure that like that, this is not 50 kilometers because it's 50 kilometers away at that angle of elevation. So this elevation line here, this going up, is 50 kilometers and 20 degrees goes in here. Also, something that could give away that it's not this that's 50 kilometers is that you're looking for the ground distance. So this distance would translate to the ground as well. How far along the ground is the airplane away? This then connects all up, makes us a nice right triangle. And we want to know the plane's altitude. So we got to find out this value here. We'll call it x. And then we need to find the ground distance. We'll call that y. So I'm just going to do a quick little resketch of that. Just a little thing here. I got x, I got y, I got 50, and I got 20 degrees. So you can resketch it. I'm just doing it small because I don't have a lot of room to do all the questions. But you redraw that if you need to, because a lot of times we draw a diagram, then it's sometimes confusing to pull data out. So I just redrew it. So what do I have here? There's my working angle. So x here is going to be on the opposite side. The 50 is the hypotenuse. The y is going to be the adjacent. So the first thing I need to find here is the altitude. So that's the x. So I need this side. I don't need the y because I'm not worried about the ground, but I do need this because there is an actual number there, 50. So I'm going to use that 50 and the x. That's going to be opposite hypotenuse. That's going to be sine. So sine of 20 degrees is equal to the opposite x over the hypotenuse, which is 50. And I'll calculate sine 20. You can either use my calculator and type in sine 20 or 20 sine, depending on your calculator, or pull out my table. In either case, I'm going to get 3420. So 0.3420 equals x over 50. Then I'm just going to multiply that 50 up there. 0.3420 times 50 equals x. And when I calculate that, I'm going to get 420 times 50. It's going to get me 17.1 equals x. And to note, the radar was 100 meters off the ground, so the plane has an extra 100 meters here as well. That's in kilometers, because we're using kilometers here. That was 50 kilometers. So that extra height is going to be 17.2. So it's 17.2 kilometers upwards in the air. Now we need to find our y value, our distance horizontally here. So same setup, except we have the adjacent and hypotenuse sides that we'll use. We could use the 17.1 here, but what if we made a mistake in our calculations? Then we'd be using an incorrect number. So let's go back to the 50 because we were given that. In this case, a and h is going to give me cosine. So I'm going to have cosine of 20 equals x over 50. Now, very similar, except the cosine ratio is different from the sine ratio. Our cosine of 20 is going to give us 0.9397. So 0.9397 equals x over 50. And then when we calculate that, 50 times 0.9397 is going to give us 47 as our x. And again, 50. I would move the 50 up and multiply to just skip the step along the way there. But we'll get 47. So we're 47 kilometers away from the radar tower. Okay. The next one here. I don't know. This question comes up all the time. I think this is like the most popular trigonometry question I think I've ever seen. So from the roof of a shorter building here, looking at the bottom of another building is a 36-degree decline. And the top is at a 47-degree incline. If the shorter building is 120 meters tall, what is the height of the other building? So what do we got here? Probably not the best written. I was trying to write this a little more succinct so it fit on my page. But we got a shorter building. We have a taller building. And then they're probably on the ground. So we're making some assumptions that they're the same height and all that kind of stuff. But so if we're up here at the top of this building and we're looking down here, then we would be declining. So we use a horizontal line here as our horizontal, and then our decline, we're looking down at this building. So we're looking down this way. That is going to be 36 degrees. And then the incline, so looking up from that angle to the top of that building, is going to be 47 degrees. And the height of this building is 120 meters. So we can put that there. Now, here we have two right angle triangles. One down here with 36 degrees, one up here with 47 degrees. We already know this height from here to here. It's the same as this one. That horizontal line is going to be perfectly parallel to the ground. So this is going to, that's not degrees, that's meters. That's going to be 120 meters. But we don't know this height here. Call that. Let's not use h to confuse it with hypotenuse. Let's call it x. So we need to find x. So that's in this triangle. 47x. Well, I don't have any other sides, so that triangle doesn't help me at all. So what do I do? Well, this triangle has a 36, has a 120, so I can find either one of these sides. If I find this side, I'll have the adjacent side for both triangles, and that will help me find the missing x. So let's find our adjacent side right here. This is our adjacent side. So that's our opposite. This is our adjacent. We're going to use the tan ratio. So tan 36, tan is opposite over adjacent. Tan 36 is 120 over A. Again, pull out your calculator, use your handy dandy table, and you get 0.7265 equals 120 over A. And if you recall, we can just swap these around so that we have A equals 120 divided by 0.7265. And then when I calculate that out, I get 165 approximately. So that gives me this A value. That's the distance between the buildings. So now I know how far apart they are. So now that I know how far apart they are, I can calculate x. So now in this triangle, I have the opposite and adjacent. So I'm going to use tan again. So tan 47. But this time I'm looking for the opposite side. So it goes on, the x goes on top, and the 165 goes on the bottom. Then I look up 47, the angle 47 in my table, and as a tan, it is 1.0724 equals x over 165. And then I just multiply the 165 by that to get my final result for x, or my result for x, and then I can add the 120 on to get my final result. So that's going to give me 177 equals x. Therefore, the height is 177 plus the 120, so that's going to be 297. So 297 meters. These are big, big buildings. These are like future buildings. So whenever you get these, draw yourself a diagram with a word problem. Draw a diagram of it. Be careful with incline. Be careful with decline. If you have multiple triangles, that usually means you're going to have to find the value in one triangle that matches with the other triangle so that you can then use that in the second triangle. So that's about it for right triangle problems.